Ladies and gentlemen, boys and girls, so the quest has finally come to an end. We finally got everything assembled in the case. We've been doing our tests and our benchmarking and stress testing and everything, and we finally have the results. Okay, so yeah, I guess this is the last part in the vlog series of my quest for better temperatures. Okay, so it's finally come to an end. And we have some really startling conclusions to draw. No, actually, no, they're not startling conclusions. They're fairly predictable conclusions based on the fact that if you have the right equipment, you will get good temperatures. And if you do the right things, you will get good temperatures, okay? So a little recap of where we started. We started off with an ID cooling Frostflow 240L cooling a stock i7-4790K. And I tried overclocking it. I'll flash up the results on screen. As you can see, the temperatures were not great, especially for a liquid AIO. And knowing that Intel's stock thermal interface material was rubbish. Okay, and as you can see, even at just 1.25 volts at 4.5 gigahertz, we had over 92 degrees Celsius on the CPU. Okay, that's just, it's crazy. All right, so what was the first step? After looking at all this crap, the first step, of course, was to delid the CPU and to use liquid metal, thermal grizzly's conductor knot, in between the heat spreader and the CPU die. And of course, we had a drop in temperatures. We managed to clock up from from 92 degrees, we dropped down to 81 for the equivalent 1.25 volts and 4.5 gigahertz overclock. Okay, which is great. It's a drop of about 11 degrees Celsius, but it still seemed to really be really high for the really small amount of vCore that was being put through the processor. Okay, and of course I tried overclocking it a bit more, going 1.3 and 4.6, and we ended up with 87 degrees Celsius. Again, you'll see all the numbers on screen right now. Not great at all. So I was thinking, okay, how do we lower the temperatures even more? Having looked at the construction of the AIO, the Frostflow 240L, and realizing that the fans themselves were not very great, they seemed more like case fans, airflow fans, rather than static pressure optimized fans, I decided to change to a Kraken X62. And lo and behold, if you look at the numbers that are on screen right now, you'll see that there was a significant improvement in terms of temperatures. Okay, so we went from 81 degrees at 1.25 volts, 4.5 gigahertz on the Frostflow, to a low of 70 degrees Celsius, okay, which was a drop, okay, of an additional 11 degrees Celsius. Okay, so then since we had a bit more thermal headroom, we could now overclock the CPU even higher, and now we're sitting at a very stable 1.35 volts, 4.7 gigahertz. After running all of the benchmarks and the stress testing, we find ourselves at 80 degrees Celsius at 1.35 volts on the vCore, 4.7 gigahertz. Very, very happy with that. That's almost a 20% increase in performance, and more than happy with it, actually. That's great, you know. And as a matter of comparison, we're going to show you I'm going to show you the different configurations for the CPU up on screen right now. We had the i7-4790K at vCore 1.25 and 4.5 gigahertz, and look at the difference in between the different configurations. Okay, with the stock paste and no delidding and the Frostflow 240L, we were at 92 degrees Celsius under load, under benchmarking and stress testing. Once we delidded, that dropped to 81 degrees Celsius, and once we delidded and changed the cooler to a cooler that has actually got static pressure optimized fans, the Kraken X62, we dropped a further 11 degrees Celsius. So there was a 22 degree drop in temperatures from the stock configuration on a liquid AIO, the Frostflow 240L, all the way down to 70 degrees Celsius. That's just wow, that's pretty awesome. Okay, so that's for the CPU. As for the GPU, we went from hitting thermal throttling at 86 degrees Celsius on the GPU to 56 degrees Celsius. We dropped about 30 degrees Celsius after we put on the Kraken G12 together with the Corsair H80i V2. Now this H80i V2 has only got one fan on it, not two. I could mount the second fan on the outside if I chose to, but that wouldn't really make much of a difference because there's so much airflow because of this fan. It's a static pressure optimized fan that I don't have to worry about temperatures. And with only one fan, it's already doing, 56 degrees Celsius, which is 30 degrees below what it was doing before. So I can say that if you have a Zotac 1080 Ti Mini, the Kraken G12 will fit, and if you decide to use a liquid AIO like the H80i V2, it will work, and you will see a significant drop in temperatures. What's the conclusion of all of this? Well, of course, money solves all problems. But if you wanted to lengthen the life of your Zotac 1080 Ti Mini, this is a great way to go. The standard heatsink and fan on it just does not work very, very well. You'll hit thermal throttling almost all the time if you're doing 4K gaming. And if you wanted to overclock it, a little bit more, why not? I managed to squeeze out a plus 160 on the GPU clock and a plus 50, I think. No, was it 30, 40? Very small on the memory clock, but still, it was pretty good. So yeah, guys, that's it. That's the conclusion of this journey, the quest for better temperatures. 22-degree drop on CPU and a 30-degree drop on GPU after installing all of these components. I'm really happy. If you guys want to know more about this process, please just PM me in the comments below and I'll see what I can do to reply. But yeah, the quest for better temperatures has come to an end. Peace out.